Okay, so our next keynote speaker is Dave Airlie, and Dave is a distinguished engineer from Red Hat and is one of the major contributors to the Linux GPU stack across the kernel and user space. Dave works for Red Hat on Linux and AI products in the GPU and accelerator space. The keynote is titled Open Source Code is Not Enough. So, thank you, Dave, for joining with us today, and over to you.
Thanks, Syed. So yeah, this is my talk today. Is open source code is not enough. As Syed said, I work for Red Hat, although we're not currently a UXL Foundation member. I've been advising on open source directions and stuff using experience gathered over the years of working on Linux kernel and other projects. So this talk is sort of a discussion and meant to get people thinking about how to move forward with the projects and stuff in the open source space from where we are to where we need to get to. So just a quick bit of a background on what projects I'm talking about. We'll talk about this discussion. The UXL Foundation oneAPI projects. There's a group of them. They mostly were initially developed by Intel over many years and some possibly even decades. They've mostly been developed by what I would call internal facing teams. Product focused, just your standard traditional development cycle. Most of these teams have probably got established development processes, which may have changed over the years as the industry has changed, but they're more likely a traditional sort of software development process. And some of these projects are often like product cycle focused. And what I mean by that is, a GPU coming out will drive the release of the project, or a new CPU release, or a new hardware release, or something like that. So this is just to give you a scope of where the UXL Foundation projects I'm going to discuss come from. So I suppose the first question we have to ask with a talk like that is, what do I mean by open source? So what is open source? There are many aspects to open source beyond the simple one, which is just code. Open source code is, everyone, that's just the base level artifact of what open source is. You have to have the code, but it's evolved over the years to mean more than that, and different forms of the development cycle have become sort of called open source. So we have, the first thing we'll go to is like the release method. So that's how does the code get put out into the world. Is we've got called the over-the-wall method, and then we also have like constant releasing type of methods. There's also, like, we'll discuss about the development methods. What does open source development mean as opposed to just the code? And then also I've added CI/CD, which is sort of a new area that's coming up a lot more. It's used a lot in projects, but what does that mean in an open source environment, and how do you deal with that sort of problem? So the talk will sort of cover most of those aspects today, and we go into some more detail. Where do open source projects come from? Like, what's the standard origin story of your open source project? I kind of, told it that there's really two sort of major types of open source project startup situations. There's either a single developer who's usually could be independent, could be at a company, but they bootstrap a project sort of on their own or with a small group. It's like, I think we call it scratching an itch. It's probably the way that the best describe it. Like, this doesn't mean the project is going to remain small. Things like the Linux kernel started as single developer bootstrap. GCC, I think GCC is probably similar. LLVM has a lot of this sort of aspect to it. Yeah, these projects are generally like, we've got one person, they've got an itch, other people start coming to it, and then it builds the project and a community around it. And the other way we see projects starting up often is corporate product opening. So something that a corporation has developed internally, and they've made a decision then that they want to open source this thing, that they, for some either for a business reason or a community reason, that this want to move forward. For today's talk, I'm mostly going to concentrate on the product opening side of things, because I think that's more where the UXL Foundation projects are coming from. And the single developer stuff I will reference, but it's probably not as connected to these projects, since they are all coming from a corporate background. So when I say corporate product development, this is kind of a diagram of what I mean. Internal product development, all of the work is done inside that dotted line. We can just consider the company boundary or the corporate firewall. Planning is done inside. This could use Jira. Is just an example, but it's a useful example to go into details on. The stuff is all developed, the product is developed, the product is released, and all of the CI/CD infrastructure is probably hosted internally in the company. This is pretty much standard corporate, development model. There's not really a lot. But what are the challenges now when we have this model already established? We're already releasing code using it and releasing products using it. But then we decide, okay, it's time. We need to open source this thing. How we want to move it into a community. How do we sort of address that? The first thing I call is the opening code is step zero. So I call it step zero because traditionally we've had discussions with many companies, and we will talk to them and go, okay, well, if you want to include that software into something like a Linux distribution, well, we need, it has to be open source. And a lot of companies then take that advice as, okay, that's all we have to do then is just open the source. And you're like, okay, but like they come back to you maybe 2 years later with the source code and say, look, we've opened the source. Now can you include it in your Linux distro? And why either we failed to communicate or what is failed to be understood is that that's the point we can start talking about it. Before that code has been open sourced initially, we can't even really discuss things with them because we don't have a playing field to even start discussing on. We don't have insight into how the code is structured or how it works. So that's why I call it step zero. It's like, you literally have to do this base amount just to even have us talk to you and be able to understand each other. So what is step zero? What does that look like in practice? We see it as the over-the-wall method, which is we get to the release stage and the source code gets pushed to an external repository. This can happen in different ways. Some projects will do a big on if def and if take out half the code and push only the pieces that can want open source out to the external project. Some companies will push all of the project out. So some examples of what like a project that this happens with, like I think Android is probably the biggest sort of example that's out in the community, that we know about. They do releases of the Android product, and then they drop the AOSP source code at the same time. But there's other sort of examples of this in the GPU space, especially. We've got things like the AMD Vulkan driver for Linux. It's an example of something where they've got a Windows and Linux driver internally built off the one source code, but the code they release externally has all of the Windows code removed. So they're doing the if-def work. And then even later than that, the NVIDIA open GPU kernel modules, which they've started recently, again, are another project which is totally internally developed. But when they get to the release, they have a stage that takes out all the if-def code and pushes out the sanitized source code. So this is your base level, open source. This is open source code. But as I said in the title, this, in my opinion, is not really good enough for what to achieve what we want. So how can we improve on this? Where can we go with it? So I call this like stage one. This is like the corporation will, let's go, okay, we want to do this. We want to create a community project. So what does that mean? Well, first of all, we got to move stuff outside the company. We have to have stuff in the community. So we move a bunch of the process out. So generally this can move into like at least the development and the release stages will go out. We may do some public planning with GitHub and something like GitHub or GitLab using like their features. But often with stuff like this, a lot of the planning is still done internally. A lot of the stuff is still focused on an internal schedule. The engineers are so used to doing all of the planning in Jira, and not just the engineers, the project managers, the team leads. They're all used to having Jira for their metrics. It's very integrated into their system. So going, okay, can we stop all of that internal development and moving all of the planning out to it? It can often be a daunting task. So it takes people out of their comfort zone a lot and presents some challenges. So we often see this kind of effort where we do have some GitHub, GitLab work, but most of the planning is still probably done internally. There's also usually a release internally where there will be an open source release, but there might also be like a product release out of that. And quite often the CI/CD infrastructure will remain within the company because the efforts of creating external CI/CD can often be, again, a challenge for a lot of companies because it often has to live outside of the firewall, has to have be hosted somewhere that's kind of not publicly, some way publicly accessible. has security concerns. So there's generally a bit of a barrier there to moving the CI/CD out. So when you get to this stage, this is kind of like, I think that we're probably a little bit past this, but not too far. It's roughly where we are. But where does this run into problems? Like why, this is hard to sustain. Well, let's pull in a second company. So we've got the model, and then another company has joined, and they're going to release their own focused version of this, and they have their own engineering staff, and those engineering staff want to do all of their planning in their internal Jira because they have project management and they have engineering management, and they want to do some CI/CD on their hardware, which is different than company number one's hardware. So again, we have that sort of dual effort now going on. We have the second company are repeating a lot of the process of the first company, and communication is often hard here, and planning is often hard because neither company has committed to using the GitHub, GitLab, or whatever infrastructure in the middle. They're just sort of using it for the interconnection, and again, this can run into problems, especially where they want a new feature and they both have started working on it internally, or one is expecting the other company to do something that they haven't done yet and has relying on that. So this starts to be starts to show some of the problems. I've added some external CI/CD. Again, often maybe at this point you've at least agreed that we should at least test the build works on everybody's architecture, on everyone's product. So we'll have like maybe a GitHub Actions or a GitLab Runner or something like that. And maybe we'll have started doing some basic CI/CD work outside, or testing at least. But yeah, this is the problem now, is how to scale. Like you get to these points, it's like, well, how do we create like the goal we want at the end is something like this. This is the project is in the middle. All of the planning, development, release, and CI/CD is all built up for the project. And you have multiple companies all doing their own little pieces, but the project is in the middle. So, and any of these companies should, in theory, be able to pull away and the project should still go. So they should all be, I've turned them into clouds because they should all be nebulous and should be able to disappear and reappear. The project should be staying in the middle as the main sort of cloud. But yeah, again, how do we start making this happen? So the way I call this a Red Hat process. I am not sure if it's a Red Hat original idea, but it's what we do internally at Red Hat for most of our work. We split everything into projects and products. We give those things different names. They often have different goals. They often have different maintainers, and sometimes they may even have different development teams. And so why is this important? Well, it lets the project live in its own space that's not got the same namespacing as someone's product. It gives you that like upstream versus downstream differentiator, that if I've got a product called, say, oneAPI, and then I try to make a project called oneAPI, well, anyone who wants to join the project will go, well, that's just your product. That's just giving Intel stuff to go into their product, instead of thinking about the project as its own separate thing. In Red Hat, like we've got things like the best example is probably RHEL and Fedora. We have now got RHEL CentOS Stream and Fedora, which are kind of serve as separate levels of the process. But there's also, we do it with JBoss and Wildfly, I think it is. But we've done this with a number of our projects. We use Kubernetes, and we have OpenShift that's derived from Kubernetes. So it's a pretty standard Red Hat way of doing things, and it works quite well. But a lot of people, for some reason, don't get this. They often think, oh, we're going to lose out on the branding, or we have a big marketing push on our company side. We'd like to keep the project engaged with that. But I think in the end, that's usually detrimental in that it stops other people from getting involved. So I think it's important that companies can still make products and still have marketing teams, and marketing teams can go on their own schedules, and the product can go on its own schedule. But the project can still exist and still have its own focus, and not have this doesn't need so much of the marketing and stuff. So again, this is, I think, a very important distinction that Red Hat does, but I think most companies that try to open source things should really engage in. Very useful, at least to keep the model in people's minds. But then we have another question that often comes up at Red Hat. It's like, well, do we actually need a product for this? Is this project we're working on actually something that should be a product? We call this generally commoditization. And when I say commoditization, I think I've done a talk for the oneAPI recently about this. What do I mean? Well, generally on the Linux scene, we mean this is part of a Linux distribution. You install Fedora, and you can just install this project on top of it, and it'll just work out of the box. There's no real product focus to it. It's just the project. Again, things like GCC, the current Linux kernel, these are all commoditized. There's no real distinction in them in terms of the products are usually built downstream of them, and the distributions are kind of the product in a lot of cases. This doesn't always work for non-Linux platforms, so there's often cases where you may need to do like a Windows release of some software, and there's no vehicle for that, so then you have to like do a Windows kind of product release. There may be cases of wanting to backport it to older distributions and things like that. But I think it's an important question to try and think that do you need a product? Like, does there have to be a product? Can we commoditize our project into such a way that it's just installed on every Linux computer automatically, or it's just there? And this has happened with things like Vulkan, OpenGL. They're called base parts of the operating system now. They're not things that need their own separate projects or products. And I think for something when we're talking about a compute stack, like the oneAPI, at least some of the components of oneAPI, it's like, should this just be a base level, everyone has it type feature? We're not quite getting there yet, but I think it's something that's important for us to think about moving forward. And this kind of leads me into a slightly, there's just a little diversion. So if we're building these community projects, who do we need involved? Like you generally need, we found it experience, there's sort of like three sort of categories of developers. You want all three. Not every developer will fit directly into one of these at any one time, but like one developer may move between these at different parts of the project. But it's important to have staff that are available, and can do all of these sort of things. Step one is called I call the trailblazer. This is generally, we need someone that I want to put oneAPI onto a new platform, or make it run on Apple M3 GPU. What do I need? So that's someone that will just do that. Like, they will just get the hardware, get the software, and they won't rest until they've reached the goal at the end of that. Examples of this in upstream Linux is, I got to give you heard of the Asahi GPU project, where they've reverse engineered and implemented a driver for that in Rust. And like, it's a great way of getting there, but then at the end, you've got this not quite finished project, but you've got what I call a path to what would look like. But the people that trailblaze don't often want to then go back and start again and build the actual road. So you then want to have people who are willing to build a project and then even build the product sort of type situation out of that they can actually construct something that's, they'll deal with all of the intersections with other people. They'll deal with the over time rebasing and the continuous updating and the checking of it, and the work to get in each individual step into a good way and getting it into the project. And then finally, you need long-term maintainers. These are people whose job is to care about the project. You need these people because generally, if you look inside a lot of companies, inside of corporate development environments, there's not really an explicit maintainer role, and which is why it's often difficult for people to understand this when we get to open sourcing. It's like, well, we don't really have maintainers in our company, but often it's a senior engineer or who's just been given enough time to clean up the code and make decisions about it and things like that. But it's a more formal role in the open source community, because we often find with projects that people want to get feature based. They're more focused on adding new things and features, and are not so focused on maintainability and tech debt and stuff. And this happens in corporate environments as well. But I think we've understood it better in the open source community that this is an important role, and we need to focus on it a lot more for long-term health of projects. So I'll just go into a little bit more on that particular role. I think it's very important for open source projects that maintainers are a funded decision-making role. They're not you're a developer, just be the maintainer in your spare time. They're not you 5 people, you all go maintain it between you. You can have group maintenance, but you have to have rules about who's making decisions at any one time, and you have to make a space for that to happen. The job of the maintainers is to create space for other people to participate. They're not there for their own product for their company, or they're not there for to make their own code successful. They're there to make other people's contributions successful and to guide the project's decisions. Again, where a lot of companies fall down with this, and we've seen this in the Linux space for a long time, is they get someone into these maintainer spaces, and then they're told that if they want to get promoted at the company, they have to go do something. This is changing slowly, but we would like to make sure that that sort of structure is in place in companies that want to get involved in projects. That maintainers are a position that is both well funded and promotable, and shows up as important to the company, not just okay, you can maintain it for a year or two, and then now you need to go and do something that's actually important. This is tricky, but we are slowly getting there. Red Hat's pretty good at this, and that we do a lot of maintenance, so we're well used to it. But I think other companies like Meta are starting to push this more, and I think Google are also getting good at it. But it's important that companies realize that the maintenance role is important. So I showed the picture earlier, but just to go into more detail on what we would call a successful open source project, I think it's important that there's multiple companies developing it. And I don't mean just their own pieces. I mean, they're developing all of across it. The companies are all involved at every level. There's some pieces that are probably company specific, but in general, the core is maintained by multiple people from multiple companies. There is not just one company carrying the burden of that. And again, the maintainers be the same. The maintainers should come from multiple companies. You want them spread out. You want them to care about the project. I think it's important that you have maintainers who are given a position where they care about the project more than they care about the product. Again, a lot of companies find it really hard to get that message, is that, look, these people have to be given decision-making process over the project, not over our products. And in Red Hat, we have a very explicit rule in our employment contracts that you are allowed to make decisions in favor of the project over the company. And I think we're the only company that has that in our engineering contracts. But it means, like, it's very rare you ever run into a problem where this matters, but it does mean that the maintainer has peace of mind that they can make decisions in the long-term interests of the project over the short-term interests of a product. So I think that's a useful thing to have. You want to have all the multiple types of developer. You want to cover the three sort of categories. You want to make sure they're coming from different companies. You want to make sure that the trailblazers and the maintainers don't annoy each other, that there's someone to build those roads between them and help them out. And I think the final kind of thing that I see for a successful community project is what I call resilience. Again, this one's really hard because it would mean that if one company decides tomorrow that they're no longer interested in it and drops all of their funding and all of their CI resourcing and all that, that the project can still continue. Now, there are projects in this position, like if you look at LLVM, the Linux kernel, the Mesa project for 3D graphics, these are have all gone through resilience testing. We've had companies depart, we've had downsizes, we've had resizes, and the projects have still come through. There's always been a scary period of time, but the project has persisted through it and come out the other side. Again, it's hard to plan for resilience. You really have to just sort of build up the structures of the above structures, and then when resilience gets tested, well, then you find out if you have that level you need. So with all of that in mind, how does that kind of for the oneAPI ecosystem that the UXL Foundation is trying to create, how do we get that? I think it's important for any companies that are joining the ecosystem that they need to start by looking at investing in the common core as much as investing in their product. I understand that's always tricky for people to get, but you need to move past I'm only doing this for my company's benefit. You need to see the ecosystem growing as a benefit. I think the thing we give is the rising tide lifts all boats. You need to see that making oneAPI successful in the ecosystem and having that set of projects be successful will help a lot of companies, and your market share will increase and your sales of hardware will increase if you're involved in that. But you need to invest in that, in the core of it. You have to be kind of willing as well to enable competitors' devices sometimes. This is something that, again, a lot of companies find difficult. We do it a lot for Red Hat because we don't really have hardware devices. But we've had cases where, say, AMD has said they don't want to enable Vulkan driver with the Mesa project, and we've gone, well, we'll write a Vulkan driver with the Mesa project and see what happens. And by us then forcing their hand on that that Vulkan driver has taken over the space. Where I kind of see this applying here would be, there's been some work to enable UXL projects on other competitor, on NVIDIA and AMD hardware. I think for it to be really successful, you have to drive it all the way down to the kernel level, to level 0, through OpenCL. You have to spend effort and time showing that you can deploy this in a possibly heterogeneous environment with multiple different vendor stuff and be somewhat competitive. And I don't think you can get to that without having done that investment in enabling the devices. That like to get NVIDIA to come on board with something like this, you'd have to demonstrate to them a value add and customer pressure and business needs. And I think without having some basic demonstration of proof of this, that's not just a high level we run on top of CUDA, but something that's more low level, it would be needed. But it's also important then with it that companies understand that balancing the new product development and the project maintenance is very important. You can spend all of your effort just making the product development for your product and assume that other people will do the project maintenance. That's not healthy for the ecosystem. It's not healthy for the project. This actually there's a good example of this in historically. I think if you look back at the way the Xorg Foundation was originally run, and I think also some of the other free Unix, the early Unix sort of consortiums, there was a bit of a tragedy of the commons in that the companies would all start off working on the core, but then realize that, well, if I don't stop working on the core, I let the other company work on the core, well, they'll have a larger burden and their costs will go up, and I'll save and I'll be better off in the long term. But in the long term, of course, the whole thing collapses because every company just wants to work on the bit that's successful, and nobody works on the core, and it all just collapses under its own weight. Again, the Linux kernel has been pretty good at avoiding this problem. It comes from a group of people who care more about Linux kernel success than their company's product success often, and the companies just sort of accepted that because that's the way they get to use the Linux kernel. I don't think they're happy about it often, but it is what it is. So so what could the UXL Foundation kind of specifically do here? I'm just sort of giving some things that it should, this is rough advice. It's not like, set in stone. You don't have to do all these things, but I think it's important that they encourage some behavior. So allowing developers involved in the project scope to help the project over their product, I think is, again, one of the sort of first things. I think it's important that any company that's kind of joining or it wants to get involved in the UXL work starts looking at how can I put my developers on the core of this. I've said Red Hat aren't members of the UXL Foundation, and this is currently probably one of our blockers on our side, is that we don't have enough developers that we think we could make a big difference, and we don't like joining things unless we think we can make a big difference. If you look at our history, I think the OpenStack project, we put 5 to 10 core engineers onto the OpenStack and drove that project largely pretty quickly. So that's the sort of thing we should see from companies joining. They shouldn't just be relying on Intel to carry this burden. But in doing that, the developers that are already in the project have to have the space and time to allow this to happen. They have to be available for the project maintenance tasks. It has to be their goal. It can't be their, okay, well, once we release this hardware, you're allowed to go off and do that for a few months until the next hardware cycle happens. No, there has to be people always on board, ready to be able to handle maintenance tasks and introduce new developers, bring on new people, do timely review, onboard their competitors. We've had problems where people are like, oh, I don't want to help AMD engineering. It's like, well, you're not really. You're helping the project, but just getting that message through to people. I think this is probably the most sort of crucial area that I would think, is that encouraging that space for projects to grow over the product. It's difficult. It's very hard to get through it, at both management level and at engineering level, because engineers, again, are comfortable being just told what to do by the JIRA and the project management, like the fact that JIRA is telling them all the details of what's happening. And this is a bit more nebulous. You don't know when new things are going to happen. You don't know when companies are going to send pull requests. So you have to find that balance across the company's commitments and the project commitments. And I think it's important to discourage some behaviors. This is maybe hard for a foundation to deal with, but if you have companies joining a foundation, but they're not contributing anything other than their name on the front page, and maybe some money, it's like, is that really helping the project? It might be help the foundation, but is it actually giving you what you need to say this is a sustainable project? And again, having members of your foundation who are singularly focused on their product and don't involve their engineering staff in the big picture and don't try to drive the big picture. Again, that is very detrimental because those people will take your maintenance time away from people who do care about it. They will want reviews of their stuff over your stuff. They will want their timelines to be respected over yours, but they won't be giving back things to make you feel like, okay, yeah, no, this is where we want this thing to go. So yeah, you really have to try to encourage the good behaviors and discourage the bad behaviors when you're trying to build an open source community project around this. So that's kind of like the main thing of the project. I've got some like a bit of a couple of sort of open questions that people should be thinking about. Where do we see the current sort of UXL projects on that scale of development, like in terms of multiple maintainers, multiple developers, multiple corporate interests, and how do we envisage moving things from where they are to the next stage? How do we, when talking to new members, how do we encourage them to the good behaviors? How do we discourage the bad behaviors? So yeah, in summary, I think this is sort of like a how do we create an open source community project from a closed source internal developed product, and how do we see the success of that? But I think that pretty much covers it.